Welcome to Data Affairs by Indra. Today's topic is statistics. What is statistics? Statistics is the science of collecting, organizing, analyzing, and interpreting data. Why do we need statistics? To make informed decisions so as to arrive in conclusions. Thus, for better decision making, we require statistics. Types of statistics. There are two types of statistics. One is descriptive statistics and another one is inferential statistics. Descriptive statistics refers to the methods used to summarize and describe the characteristics of a data set. Basically, it is used in summarizing of data. Next one is inferential statistics. Inferential statistics involves making predictions, inferences, or conclusions about a population based on a sample. It uses probability theory and statistical models to generate findings from a sample to a larger group. We will later on move on to know what is sample, what is population. We will discuss this later. But basically, from starting onwards, I must say that there are two types of statistics. One is descriptive statistics, another one is inferential statistics. Let's move on to a key difference between descriptive statistics and inferential statistics. Aspect of differences would be, first of all, let's see the definition. Descriptive statistics summarizes and describes data. Inferential statistics makes inferences or predictions about a population based on a sample. What is the purpose of this both statistics? Descriptive statistics present a clear and simple overview of dataset. Inferential statistics generalize, estimate, or predict population parameters. Techniques that we use are mean, mode, median, standard deviation, ranges, interquartile ranges, etc. Inferential statistics involves techniques like hypothesis testing, regression, confidence intervals, etc. Methods used are tabulating data, calculating averages, plotting histograms, box plots, etc. In case of inferential statistics, we go for t-test, chi-square test, ANOVA, regression analysis, and so on. Scope. It describes data at hand, and here makes predictions or generalizations beyond the data. Use. We use when we have the complete data or need to summarize data. This is very much important. Where do we use descriptive statistics and where do we use inferential statistics? Descriptive statistics is used where we have whole lot of data. We have the complete entire data, and from that data set we want to come to various summarizations, like we want mean, we want median, we want mode of that particular data set, how many times a particular number is being repeated, what's the maximum quantity to which a particular data set is recorded. This kind of a data set, data analysis can be done in case of descriptive statistics. Where do we use inferential statistics? It is used when working with samples to make inferential about population. Now, what is population and what is sample? Let's take an example. If we say that an election is taking place, okay, in election, what do we do? Various election sites, there an election is happening, and there is an exit poll where sampling is basically done. What do we do in that exit poll? After the polling of the elections, there happens to be an exit poll before the declaration of the results, as we know. In that exit poll, a sampling is done. What's that is sampling? We take a few of groups of examples of whole lot of a population, and we try finding out from that group what where do we arrive in that in those particular data, in those particular specific data sets, what conclusions do we arrive, and then we try to manipulate it so as to arrive in such a situation that we get a tendency of what if we do it for 100% of a population, the result would come. Okay. So let's see. So this we have learned. Statistics. It is the science of collecting, organizing, and analyzing data. Why do we require it? We require it for better decision making. Okay. So facts or pieces of info that we can be measured. Basically, data is something that can be measured. If we say IQ of the class, it's equivalent to IQ of the students of the class. This we should understand. IQ of the class specifies the IQ of the students of the class. Now, if we consider a class such as class 5, it's the whole population. And if we know that there are 50 students in that class 5, from that number of students, if we randomly pick 5 students so as to get an idea of what the IQ of those particular students are, and suppose we do have only data of those random particular 5 students only, from that 5 students if we try and try to achieve to reach to a data where we can say that what the tendency of the IQ of whole students of the class 5 is, we come, that means we are trying to come to a solid conclusion that what the IQ of the whole students of class 5 is. So therein we are going for an inferential statistics. And if suppose we have class 5 wherein there are 50 students and we have the data set of IQ of each and every students of class 5, that is we have the data set for each 50 students. From there we can calculate each and everything what we have as a central tendency for mean, mode, median, each and every aspects of calculations or data analysis we can do. So if we have whole lot of a data set for whole class, we go for descriptive statistics, and if we don't have, then we do sampling, and from there, from sampling, we try to arrive to conclusions for having an idea of the whole lot of population. So through sampling, we try to gain an idea of whole population. Types of statistics, thus we have dealt, it's descriptive statistics, and next one is inferential statistics. For example, marks of first sem 84, 86, 78, 72. Likewise, there is a mark for 20 students. Say. Now, in case of descriptive stat, we can ask a question. What could be a question for a descriptive statistic? It would be like, what is the average marks of the students of this class? what we will do? We will sum up all 20 marks for each student and then divide it by the total number of population, that is 20. Okay. Here we have, since we have the total number of students as 20, therefore we will divide it by 20. So we will have the average marks of the students of the class. Likewise, the question might be asked in terms of percentage, in terms of percentile, in terms of mean, in terms of median, mode, and standard deviation, and so on. So all these are the questions for descriptive statistics. Inferential statistics is what? We will have to arrive to a situation so as to gain a knowledge about a sample, and from there on we try and have an idea of that sample, and we predict to reach to a conclusion for the entire population. So this is the example that we were taking, like elections were to be happening for Goa, UP, and so on other states. Exit poll where sampling is being done. This is the entire population, upon which we take a chunk of populations, chunk of people from the entire population, and it is distributed, wherein we try to get idea of those particular samples. We take 5-6 samples as an all, and we try and get conclusion of those samples and then relate it to achieve an idea so as to predict for the entire population. Here we must note that population is expressed in terms of capital N and sample is expressed in terms of small n. This is a particular notation for these terms. Now, sampling technique. Simple random sampling. This is the first sampling technique where every member of the population, that is capital N, has an equal chance of having selected first sample N. Okay. So selecting subjects random without replacement basically. In case of exit poll, what is happening? That we are randomly picking people out of the location in that city so as to get an idea of what their version of exit poll is. Okay. Next, stratified random sampling, where population N is split into non-overlapping groups. Stratified means strata, layers. So groups of similar subjects called as strata. Stratified samples are chosen in each strata and then combined. More complicated than simple random sampling. In the first case, where in case of simple random sampling, what happened? We just took various samples. And here, in this case, we are categorically trying to achieve so as what we are calling is a strata, and then we are picking basically groups of similar subjects. Okay, more complicated than simple random sampling, non-overlapping groups. Like we are categorically criteria has been picked up as gender in survey. Like if we say that in case of SSC analysis, this is a demographic survey that occurs. In that demographic survey, such as gender criteria is there. So the criteria that are categorical in nature, like gender, okay, age classification, all these are becoming as a stratified random sampling. Systematic sampling. In a population N, every nth individual is basically may be taken as a sample. Every nth individual may be selected as a sample. Like we have 10 people in a class. If we say that in case of simple random sampling, what will happen? See this example carefully. We have 10 people in a class. In case of simple random sampling, we are telling that we are going to pick a random 2 students from out of the 10 students that we have in the class. In that case, if we are denoting it as 1, 2, 3, 4, 5, 6 and so on to 10, we may pick 2 and 9, or we may pick 1, 2, we may pick 3, 7 and so on. Any 2 people can be picked, and it is basically random in manner. It might be a girl, it might be a boy, anyone. It might be that both people who have been picked, both are girls, both are boys, or one is girl, one is boy. Any of these chances are happening over there. In case of stratified random sampling, we are just categorizing it. Suppose we are mentioning a criteria that only the male would be taken in this survey from those 10 people. So what will happen? Let's say in those 10 people or 10 students, we have only 6 boys and 4 girls. So we are on this basis of classification, we are tactically reducing our sample number to from 10 to 6, and out of that 6 we are having our sampling so as to get an idea of the entire population of 10 students. Again, we may also arrive to a choosing pattern, as if we may choose one boy, one girl. This also might be as in a random kind of a situation. Suppose there is 4, as I said, that there are 6 boys and 4 girls, and out of that, one boy and one girl would be chosen. So I have basically classified the boys and girls as in a gender classification has been done. And this type of strata has been laid on so that in case of stratified random sampling, we arrive to a more conclusive evidences of statistics. Now, as we move into the systematic sampling, what happens? That we have that particular class wherein there are total 10 students, and we say that every second student will be picked for this survey. So what happens? Every even number student is being picked up till 10. So 2, 4, 6, 8 and 10 are the number of students, basically 5 students. If I say this as a roll number, if 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are the roll number, are those 10 students in the class, and those 10 students are basically the entire population of the class. So out of the entire population of 10 students, we are picking only 5 in this case, and these are all even numbered roll number students. So this is basically systematic sampling. And then moving on is convenience sampling. What happens? It might be dealing with specific topics, like N is limited to people having knowledge in a specific topic from the particular population sampling is done. Okay, like a survey form is circulated in a data science channel. Now 1000 people fill the form since they have interest in data science, and from that few of them are chosen as samples. So out of those 1000, first of all we need to understand that out of the entire population we are only getting 1000 people, as in a first screening has been done. Those who have interest will fill up that form, and only 1000 people have filled that form. So first screening has been done, and from that 1000 people only, we are going to attain to a situation wherein we will be picked few of the candidates, as in for the final selection, as in for final sample. So entire population get reduced to samples, and from those samples we are trying to achieve to a conclusion that do they have an interest, what sort of an interest levels, and what sort of a knowledge do they have in towards basically data science. So this is basically this convenience sampling is basically domain specific. Now let us move to variable. Variable is a property that can take any value. So variable we have read, x is a variable, y is a variable, z is a variable. We say that let this be x. So we are considering that any categorically that this we take it as x, and x might be 1, 2, any value. So like height is a variable, and we see 182, 178, 168, 150, 170. So if we consider these particular 1, 2, 3, 4, 5 are the 5 heights of the peoples which we have taken into the data set. Like weight is also a variable. Okay. So there are various other examples also. We may take ages as a variable. Anything that we are considering as a group data, and we are considering it to be variable. There are two kinds of variable: quantitative variable and qualitative or categorical variables. Quantitative variables are what? Measured numerically. Like we may add, subtract, multiply, divide on these variables. Example: age, weight, height. Qualitative variable or categorical variables are example: gender, blood group, okay, t-shirt size, IQ. There is a range on this IQ basically 0 to 10, 10 to 50, 50 to 100. This might be anything. I have just considered this to be 0 to 10, 10 to 50, 50 to 100, and so on. So based on some characteristics, we are determining a categorical variable. So variable, it might be quantitative, it can be qualitative or categorical. Again, the quantitative variable can be discrete or continuous. Discrete is whole number, as in number of bank accounts of a on. If we have a data set where we are getting as number of bank accounts, what can be the answer for this question? It can be 1, 2, anything, any positive value. Number of children in a family. It can be 0, it can be 1, it can be 2, it can be 3, from 0 to the positive figure. Again, continuous variable, it can be basically all the numbers, that is the whole numbers, and at the same time the decimal numbers are also being included. The height, it can be 172.5 centimeter, it can be 162 centimeter, it can be 163.5 centimeter. Weight, so a particular number as well as the decimal places are also considered in this. As you can see, weight 100, it can be 99.5 kg. Amount of rainfall 1.1, 1.25 inches. This 1.1 is inch. Or you can say in case of millimeter also, millimeter rainfall is also calculated. So if you see this criteria, now there are a few examples. based on this criteria. Like what kind of variable is gender? Gender is qualitative or categorical variable. Marital status. What can be the answer? Married, unmarried, divorced, anything like that opposite word wherein we are not getting any numeric figure. So it is qualitative or categorical variable. River length. Here we will get numbers. Okay, but numbers, this is quantitative, and at the same time this is continuous because decimal places would come. Population of state. Population of state, this is also what? It would be a numeric figure, and what would be the result? It would be a quantitative, but it would not be a fraction value. So discrete. Song length, this can be in minutes, seconds, combination of it, therefore it is quantitative, continuous. Blood pressure. Blood pressure is also quantitative, continuous. Pin code. Pin code is quantitative and discrete or categorical. Next, variable measurement scales. There are 4 different types of measured variable. Those are nominal data, categorical data is the class, colors, gender, types of flower. Next is ordinal data. Order of data matters here. Interval, order, value, both matters. Natural zero, not present. Just go through this. I will be explaining this whole 4 thing. Ratio, data. So these are the 4 types of measured variable. Variable measurement for scales. So these 4 we will be dealing it in the next class. Beforehand, I should start with this. Wait. So I think we have seen this. This is descriptive statistics, inferential statistics. Let's go by the syllabus. And then here, C. This we will do. Here's an example. Like data. Data is what? A collection of facts, observation, or measurements. Anything that can be measured is basically a data, and a collection of data gives us info. That is information. Statistical data is thus where we can and it can be classified and analyzed so as to get conclusions. Types of data. Types of data is qualitative data and quantitative data, which we have seen in terms of variable, and qualitative would be non-numeric, which we said as categorical variable, classified into categories, example gender, color. Quantitative data is numeric data that can be measured, like height, weight, age. So in quantitative data, we see in 2 types, as in discrete and continuous. Discrete can take specific values like number of students in a class, it can't be a fraction value. Continuous data can be a fraction value, like height, temperature, and any value within a given range it can take. Okay. So if we have this kind of a data set, sorry. So we can go for organizing of data. Data is basically organized in rows and columns, and rows and columns sums up to a tabular form. So the horizontally which we move from left to right gives us the rows, and vertically from top to down is columns. I think we have seen this in table. If you want to see, you can see it over here. These are columns and these basically are rows. Okay, so thus data can be of two types basically. What we have as in two types: raw data, that is ungrouped data. These are basically raw data in terms that whatever data we have, in terms that collection, when we collect first data, all those initially collected data are in terms of raw data only. Ungrouped data is a collection of individual values or observations without any categorization. That is, we are not categorizing anything or grouping anything. Suppose the ages of students in a class are 12, 15, 16, 15, 14, 12, 18, 19, 14 and 17. This is the raw data, which is ungrouped. Characteristics of it is it can be in the form of numbers, it can be in the form of words or any other form of data. It is difficult to analyze directly in its raw form, especially when the data size is large. Here the data figure is small, data set is small, but it can be a long figure. Like consider it to be of whole school if we have this kind of a data set, that ages of the students of whole school. So it would be a bigger chunk of a data set, as in we go for group data. Group data is a data that is organized into classes or groups. So we are grouping something. This is done to simplify the analysis and interpretation. Frequency distribution is basically how many times or something is being repeated. So group data is often presented in frequency. It is basically number of times it is coming. Distribution table presented in frequency distribution table, where data is divided into intervals called class intervals, and the frequency of data points in each interval is recorded. Example, a data set like the ages of 30 students is being given. We can group the data into intervals like age group. Class interval will be 10 to 14 years, 15 to 19 years, 20 to 24 years, and 25 to 29 years. This 10 and 14 are inclusive, 15 and 19 are inclusive, 20 and 24 are inclusive, and 25 and 29 are inclusive. That means there are 5 people, okay, within the class of 30 students, wherein they have ages between 10 years and 14 years and inclusive of 10 years and 14 years. That means any of those 5 students may also have an age of 10 years or may also have an age of 14 years. So if we sum up this data, 5, 8, 12 and 5, this sums up to 30, which is the total number of students in the class. So here we are grouping something and we have a class interval. This is what is written. The data is organized into class intervals 10 to 14, 15 to 19, etc. And each interval has the corresponding frequency. This is frequency. How many number of students are having ages between 10 to 14. So there we have seen that 5 students are coming within that range. I think for this class this is enough, and from next class onwards we will be starting from the measures of central tendency, wherein we will be seeing mean, mode, median, and thereby in the next class we will also move on to the standard deviation, or in the after that class also for the next class we may also see the interquartile range. There will be plotting of histogram, box plot, and so on. So that's it from me on this side today. Thanks, and don't forget to like and subscribe. Thanks a lot.